So welcome in everybody. Happy Halloween minus 7 days. So welcome in. We're going to be going over an arithmetic reasoning review, which is going to be a culmination of the 3 previous classes that we've done. So this is the one time before class starts where someone who hasn't been to the previous classes or watched the recordings, this is going to be a time where we can kind of give you a little bit of an advantage or a heads up as to what's about to come. So, everyone, if you were here in yesterday's class, what topic did we do in yesterday's class? What topic did we do in yesterday's class? Grizel, thank you, Unit 5. But what is Unit 5? V, thank you for expanding on Grizel's statement there. Distance, rate, and time. Grizel, that's right, that's rate. Yeah, so the topic that we did yesterday was distance, rate, and time. Okay, who remembers what class we did last Tuesday? What did we do last week on Tuesday? Because again, we're doing the 3 previous math classes. We're mixing them all together. So yesterday, again, we did distance, rate, and time. Yeah, last Tuesday, we did y equals mx plus b. We did linear equations word problems. Exactly, that's exactly what we did. And then we had one more unit that we did last Monday. What concept did we work on last Monday? What concept did we work on last Monday? Who remembers? Someone already said it in the chat box. Someone already said it. Yep, proportions. Proportions. So these are the 3 previous classes that we engaged with. We went ahead and worked on distance, rate, time, linear equations word problems, and proportion word problems. And so that is the bulk of today's class. So that's as much of a heads up as I'm going to give you. I'm not going to tell you which problem I'm about to show you. I'm not going to give you any of that information. This is all you get. So any formulas, any notes that you want to use, feel free to use them. Because remember that the point is, until you get to the point where you are confident and you are quick and you're doing things mindlessly, we have to be mindful. So if you want to use your notes, I'm not going to knock you for it. Feel free to do so if you believe it's going to be necessary for you to get a good grip on what's going on today. And if you feel like after the first 2, 3, 4 questions, you don't need your notes, then hey, at that point, remove them. But if you need to use them, feel free. I want you to be able to talk about what you're doing, but at first, let's go ahead and see what we got and try our best. So, sounds good, Rizal. I'm glad you're ready. So welcome to practice time. We are going to go ahead and go through a gauntlet just like we've done before. And we are going to give ourselves 2 minutes and 30 seconds per question. 2 minutes and 30 seconds per question. And we are going to do the first 5 back to back to back to back to back. All right? First 5 questions back to back. We review those 5. And then for the rest of class, we are going to enjoy timed practice. Everybody give me a ready in the chat box if you are ready. Right on, right on, right on. So if you're just joining us now and this is your first class, this may be a little awkward. My name's Coach Anderson and I am Taco Tuesday for Halloween. And we're not having class next Tuesday, so that's why I'm dressing up today. So with that, let's go ahead and get this timer situated and then I'll remove my face and see the surprise of those who are going to join during the first question. So let's get this timer up. Remember everybody, do your best. You are not here to compete with anybody else other than yourself. So 2.5 minutes per question. 3, 2, and 1. Give an answer, because remember on the actual test, there's no penalty for guessing. If you guess right, great. If you get it wrong, well, you got it wrong. All right, let's go ahead and dive into the next one here. Remember, we are doing 5 questions back to back. This is the first of 5. Here's number 2 in 3, 2, 1. Again, don't share your answers until time is up. Simply type ready when you're ready. Even if you are completely lost and you have no idea what the answer might be, just put an answer. Go ahead. Totally fine, because we want to basically understand how far we can go on our own That way, when we review these questions together, we can figure out, hey, this is the point I got stuck at. I really want to pay attention to this part, and then we'll move forward from there as best we can. But if we're unable to identify where we're stuck at, then it makes it a lot harder to kind of, dig ourselves out of that hole. So we really have to think about it in that way. Try your best, get as far as you can, and get ready to articulate how you got stuck or where you got stuck. Here we go. Question number 3 out of 5, coming up in 3, 2, and 1. Remember to start with the question first, that question sentence, because remember, no matter who you are, you can always identify what the question is asking you to find. So remember, always start with the question sentence and then move forward from there to gather the information. Okay, I'm glad you were taking notes too. So here we go. Question number 4, 3, 2, and 1. All right, here we go. We're diving into number 5, diving into question number 5. Again, this is the last one, and then we are reviewing and then getting more practice. So here we are, 3, 2, and 1. So first things first, let's go ahead and go back to question number 1. All right, so my poor people, let's go ahead and get this timer out of the way. And for those of you who joined, between the first question and now, you have to find out the hard way. Today is Taco Tuesday. So let's go ahead and get things started. So here we go. First things first, everybody. What's the first thing that we're supposed to do when it comes to any word problem? Right, first thing we're supposed to do is read the question. That's right. So with that said, when we read the question, we'll go right over here. Again, the question sentence. That's the first thing we want to do. So right here. About how long will it take to fill the container? So about how long will it take to fill the container? Okay, I'm not going to look at the chat box right now. So again, about how long will it take to fill the container? My party people, what is it that we're looking for? What type of unit, or what do we know that we're looking for? We can look at the answer choices. What is it that we're being tasked to find? Yep, we're being tasked to find time. We can take a look right over here. It says time. Everything here says minutes. So we're looking for a time period. Now, is that automatically going to tell us what topic we're doing? No, but it's going to give us a hint in terms of the direction we should be pointing ourselves in. We're trying to find a time period. Okay, sounds good. We're trying to find the time, and we want to know how long it'll take again to fill. About how long to fill the container. So we can write that here. Time to fill equals blank minutes. Okay, now next up, this is where we're going to go into part 2. Part 1 is what do we want? Part 2 is now what do we have? What information do we have? Let's figure out what topic this is. So when we go through, it says that we have a 600-gallon container is being filled with a liquid at a rate of this many gallons per minute. But we have a leak that's causing the tank to lose this many gallons of liquid per minute. Okay? Then it says the container currently has 75 gallons of liquid in it. So about how long will it take to fill the container? Now, if you thought that this question was familiar to yesterday's class, it very well is. But this is probably one of the more complicated ways that this question could be formed. So, everyone, remember, anytime in a problem that you can spot a rate, technically speaking, you're dealing with a distance rate time word problem. So everyone, do we have a rate given to us in this problem? Yeah, so we do have a rate given to us in this problem. I swear, every time I look at the chat box. So yes, we do have a rate given to us in this problem. We do see that we have 25 gallons per minute. And that's what it's being filled with. That's the fill rate. But then we have a leak that's causing us to lose 6 gallons per minute. So we have 2 rates. Okay. And then we have what we're trying to get to, the 600 gallons. Then we have the 75 gallons that are already there. This can feel very, very, very confusing. But nonetheless, my math party people, we can do this. We can absolutely do this. This is going to be a distance, rate, time word problem, and it can also be considered a y equals mx plus b word problem. Either way, it'll both work out. To make things or keep things simple, I'll just go ahead and keep this as a distance, rate, time word problem for the time being. Distance equals rate times time. Again, you could use y equals mx plus b for this. Absolutely. Absolutely. So here's how we're going to get this done. Remember that when it comes to a distance, rate, time word problem, we need to make sure that what we fill in is consistent. Everyone, what does the time represent here? Again, I know it's minutes, but what do you mean? How many minutes until what happens? How many minutes until what happens? What do we look, what does that time represent? How much time until what happens? It's highlighted there in red. Which one is it? Yeah, the amount of time it's going to take to fill the container. Why is that important? Because it's going to instruct us how to set up our formula. Again, talk about it in English. We want the time it takes to fill the container, so we want the rate it's filling at, and we also want to know the distance or the amount of liquid that we need to fill. So again, it's all about filling the container. My party people, before I continue, does that make sense? Everything that we're going to plug into the formula is going to be consistent with filling the container in terms of this situation. Yes or no, does that make sense? We're about to dive in right now. Excellent. Again, this is one of the more complicated examples of this type of question, but it can be really split up and conquered one bit at a time. The first bit that we're going to talk about is the distance. Let's talk about this first. Let me highlight this in blue. So let's talk about the distance that we are trying to achieve. We see here that we have the 600-gallon water or liquid container, and we also see that we currently have 75 gallons of liquid in it. So my party people, if we have 75 gallons here, we start at 75 gallons and we're supposed to end at 600 gallons. My party people, what distance are we covering? How much liquid do we need to fill from where we are to where we need to get to? How much liquid are we filling? John, Cedric, appreciate that. Yes, to get there, we absolutely need to subtract. Because if we're starting at 75 gallons and we end up at the 200 or the 600 gallons, if we subtract those two amounts, 600 minus 75, that's going to give us 525 gallons to fill. My party people, does that make sense? 525 gallons is the amount of liquid that we are going to fill. We already have 75 there. We need to get to 600. So if you take the difference or subtract, you'll see how much is left to fill. Great. So again, one more time, does that make sense, my party people? Yes or no? Everybody, go ahead and let me know. Because we're going to take this one step at a time. We have the distance down. We're looking for time. Now we need to make sure we plug in the right rate. So if we try to visualize what's going on, I'll go ahead and help us visualize by just drawing a little container. Not a parallelogram. That was weird. Cool. So we have our water container. And I'm just going to go ahead and draw this example out as quickly as I can. So bear with me. 1, 2, 3, 4. Right there. Cool. So we are filling at a rate. So I'll use, let's go ahead and use purple or green. I'll go ahead and use green to show the fill rate. So we see that it's being filled at a rate of 25 gallons per minute. So we have 25 gallons per minute going in. And then over here it says, and don't worry, I'll zoom in a moment, but then it says that we have a leak, and the leak is causing the tank to lose 6 gallons per minute. So we have a leak, we're coming out 6 gallons per minute. So my party people, let's talk about this in English. Let's think about this in terms of minutes. Bear with me. Come on, center with me here. We're talking about this tank of liquid. We count 1 minute. In 1 minute, we poured in 25 gallons, but then 6 gallons came out. So everyone, what was the net change? What happened there? In 1 minute, how much liquid did we actually gain? If we put in 25, but then we lose 6 gallons, how many gallons did we actually gain in 1 minute? I see a lot of us, everybody here saying 19. How did we know to do that? We knew to do that because losing 6 gallons per minute means that we are taking that away from what we're putting in. We add in 25 gallons and 6 leak out every minute on the minute. So to get the true rate that we're going to be dealing with, everybody, to figure out how fast we're actually filling up this tank, we need to account for the leak. And so therefore over here, 25 minus 6, that's going to equal 19 gallons per minute. And that is going to be the true rate. That's the rate that we're filling the tank up at, truly or technically. Yes or no, before I continue, does that part make sense? Cool. Great. So that's really what we need to understand. We have the distance, which is the amount of liquid that we're trying to add into the tank. So we have 525 gallons to go right over there. And then number 2, what's the actual rate? We're plugging in 25 every minute, 6 comes out every minute, and that's how we get the 19. So let me zoom on out and let's get this out of the way. Please. Let me go ahead and see if this will feel like. There we go. And we'll move that right over there behind my big old head. Got to move my taco shell for this one. I just realized the green screen's basically stopping you guys from seeing about half of this, but it's all good. So here, we'll go ahead and plug in the 19 gallons per minute. And then T, we zoom on in, and here we go ahead and solve. My party people, once we're here, what do? We have the distance, we have the rate, we're looking for time. How do we get that time by itself? Right, we'll divide both sides by 19. We'll divide both sides by 19. So therefore, right over here, divide by 19, divide by 19. And so it looks like we'll need to do just a little bit of long division, which isn't going to be anything crazy. 19 goes into 525. Let's figure it out. Everyone, how many times would 19 go into 52? How many times would 19 go into 52? You can take a guess as well. Right, for us here, that'll be twice. 19 times 1 is 19, times 2 is 38, times 3 is 57. So not gonna work. 3 won't work. It'll be 2 because 9 times 2 is 38. So now what we have here is 14. We drop the 5. And so we ask ourselves, how many times does 19 go into 145? Any guesses here? Some of us are saying 6. Some of us are saying 8. Well, let's go ahead and let's try 8. Let's try 7. Let's go ahead and just try 8. Let's go. So we'll try 8 here. We'll do 19 times 8. And so we have 9 times 8, which is 72. 1 times 8, which is 8. Carry the 7 is 15. So 152 is a little too high. It'll actually end up being 7. So we'll have ourselves 27. And so when we multiply 19 times 7, what do we get? We have ourselves 9 times 7 is 63. 1 times 7 is 7. Carry the 6 is 13. So that's going to be 133, leaving us with a remainder of 12. So from here, we can actually stop because we know that we're going to have 27 and then some decimal. We know we're going to have some decimal, but if we're trying to round this, because it says about how long, so we know that we're going to get an answer that we need to round up to. Since we have 27 and change, what's the only answer that we can pick? Right, 28 is the only answer that we can pick, so that's the one that we'll choose and we'll go with. And so there it is. Answer is B, 28 minutes. Now again, I'm going to be very honest and very forthcoming about this one. This first question that we're doing here is one of the tougher ones that you may see because you're not accounting for a easy distance rate time, or y equals mx plus b, you have basically different conditions that are set. It's not one simple rate, it's actually two rates where we have stuff coming in and stuff going out. And we have to figure out what that net rate is. Same thing with the distance. We weren't given how much we actually needed to fill. We were given how much we had and how much we had to get to. So what was left was up to us to figure out as well. Everybody, do we see that? This is a straightforward distance rate time question, but we had to do a little more work to understand what distance and rate would be. Let me know if that makes sense. Perfect. Yeah, feel free to take a picture. Let me go ahead and get myself out of the way. And this is crazy. You can see that the green screen, it absolutely takes away all the lettuce here. So I should have thought that through. Probably should have got a different costume. But there we go. Let me go ahead and get my face out of the way. There you go. 5, 4, 3, 2, and 1. All right, so we are back. Now let's go ahead. You thought it was sour cream? Oh man, I can see that. Hey, yeah, no, this is all lettuce. Everything that you see going through me is lettuce. So with that, let's go ahead and move forward to number 2. Oh wait, let's see. Yeah, Chiari, any question that has a rate in it can be solved with the distance rate time formula. Yeah, can. You can choose other things. If we have a start point, end point, rate, and time, you could use y equals mx plus b. If you just have a straight up distance, you can just keep it as drt. But y equals mx plus b and d equals rt, those two formulas really mean the same exact thing. They really do. Yeah, go ahead. Here you go. I'll let you take that picture right there. Now I really do look like a taco. This is great. 4, 3, 2, and 1. All right. So here we go. Next question. Yes, very crunchy. So next question here, we're talking about Anthony's bike trip to the beach and back. This may seem familiar to those of you who were here in yesterday's class. So here we go. First things first, we want to read the question. It says, how long did the trip home take if the trip to the beach took 7 hours? So what we want to understand, again, that this is the two-pronged approach. We want to know how long the trip home took. So here we have the trip home. And we want to know the time for the trip home. But at the same time, if you take a look over here, well, we have ourselves, let me use blue. What we see here is that the trip to the beach took 7 hours. So everybody, we're looking for a time period, but then the question just tells you that, hey, yeah, the trip to the beach took 7 hours. Is 7 hours going to be the answer automatically? Right, no, it's not, no. Just because you see the exact same unit there, that doesn't mean that that's going to be the answer. We have to understand, everybody, that in this question, we're talking about from your home to the beach, and then from the beach back home. 2 scenarios. Everybody, do we see that? This problem is split up into those 2 categories. On one hand, we're talking about going to the beach, and on the other hand, we're talking about going home. Yes or no? Does that make sense? Cool. Cool. So we'll write this here, back home. Let me go ahead and use the pen. So back home. All right. So we'll write this time back home equals 7 hours. All right. Sounds good. Now let's understand the rest of the information. So here, Anthony biked to the beach and back home on the same route. That doesn't seem like it's very important. There are no numbers in there, so why do we need to read that anyway? Well, everyone, do we need to read that? Does that mean anything? Anthony biked to the beach and back home on the same route? Does that mean anything at all? Oh, some people here are saying yes. What does it mean? What does it mean? What does the same route mean? What does that mean? What does that mean? Same route, what does it mean? It means the same distance. That's right. If we say that we're taking the same route, that means it's the same distance. So whatever distance we find for the trip home, it'll be the same as for the trip to the beach. It'll be the same thing. So here, let me actually correct myself. Let me go ahead and say trip to the beach. To the beach. Just noticed that. Sorry about that. Long day. So with that, let's go ahead and write down the rest of the information. We see that on the way there, Anthony biked at a rate of 3 miles per hour. So we'll go ahead and take that as data to the beach. So on the way there, 3 miles per hour. Great. That is a rate. And then if we continue, it says biked at a rate of 7 miles per hour on the way back. Okay, so on the way back, 7 miles per hour. We have the rate back home, 7 miles per hour. All right, my math party people, so there we are. Is everything set up correctly? Is everything set up correctly, my party people? I went ahead and highlighted quite a few things. You guys tell me, is it set up correctly? We do need the distance, we do, but everybody go ahead and check the work that I've done so far. Check the work that I've written. Is there a mistake? There may be, like I'm repeating myself, so there's probably a mistake. Where's the mistake gonna be? I'm surprised no one brought it up. What's wrong? What's wrong? What do we need to correct in terms of what I put down? Booyah. Jalen, thank you. We have to make sure that we are verifying the information, because if you check this out over here, what do we have here? This is the trip to the beach. Okay, it says here in blue that the trip to the beach took 7 hours. And so we should actually have this in red and then this in blue. We're looking for the trip home, how long the trip home took. So that's what we want over here. We have 7 miles an hour over here. Or 7 hours, excuse me, here. We have 7 hours here. Because it says, how long did the trip home take if the trip to the beach took 7 hours? So we need to make sure that we verify the information, because one slip up in the setup spells failure no matter what, unless you get extremely lucky and you can still point some things out. So with that said, again, trip to the beach, 7 hours, we have that there. We have the rate to the beach, 3 miles per hour. Now we're good. Here we're looking at back home, that's the question, and we see that we rode at 7 miles an hour on the way home. So now if we look at this side here, since we have the same distance, if we calculate this distance, we can plug that in over here. Let's find that distance. So distance equals rate times time. Our distance will be 3 times 7. Everyone hit me. What's our distance going to be? 21, that's right. That's 21 miles. And we've already said it. We said that again, these distances are the same. So I can plug that distance in over here and we can figure this out. Distance equals rate times time. We plug in what we have. 21 equals 7 miles per hour multiplied by the time period. And so here what we do is we'll simply go ahead now and divide both sides by 7 to get the answer. Everyone, 21 divided by 7 gives us what? Yep, that's going to be time is 3 hours. 3 hours, right there. We're done. And that'll be the answer here. And so to make sure that we can still get the extra practice that we need for similar questions like this, remember that this is going to fall under arithmetic reasoning unit right here. Arithmetic reasoning unit 5. Distance, rate, and time. So again, it really does take a little bit of time to get this down, for the simple reason being that the first thing you'll learn is going to be the basics of distance equals rate times time. Beyond that, you're going to learn the different situations that you can be exposed to, like having two rates, having two scenarios, having something pouring in with a leak coming out. You have to be ready for these situations by first going and starting with the fundamentals and then building on top of that. So if you felt like you were a little confused with this one, no worries, that's a natural feeling, especially when we're compiling so much together at the same time. So let's move forward here into this third one and take a look at another question that could be shown. It could be shown as a distance rate time question, and it could also be shown as y equals mx plus b. All of these questions could have been done in that way, but it's really all about understanding what method is the most efficient. So everyone, what are we looking for in this one? We read the question sentence, and it says, at what rate was Anthony reading? So everyone, does the problem give it away? What is it that we're looking for here? What is it that we're looking for here? Nice, yeah, we're looking for the rate. It says, at what rate was Anthony reading? So it says it there, and it also exposes itself in the answer choices, pages per hour. The word per is really what gives it away. So if we want to find the rate, again, rate is pages per hour or pages divided by hours. That's what that is. So if we take a look at what we have, we see that it says, well, Anthony had 1,273 pages left to read in his book, and after 9 hours, only had 670 pages remaining. At what rate was Anthony reading? So again, you could treat this like a distance equals rate times time. You could also treat this like a y equals mx plus b. And I'll go ahead and just show you the setup for both. Again, this could be arithmetic reasoning, unit 5 or 6. You know, this can be shown in both ways. So using distance equals rate times time, everyone, we know the time. We know that that's going to be right over here. That'll be 9 hours. But if we want to know what that distance is going to be, well, we need to understand how many pages were read. Because again, if we're looking at the rate that Anthony's reading at, we need to know how many pages Anthony read to know the distance. We need to know how long Anthony was reading for to get the time. So we have the time, but the distance is a little weird because we have the start number of pages left and the ending number of pages left. So if we subtract them, everybody, is it true that we'll get what we need? Is it true that if we subtract them, we'll get what we need? Absolutely. Absolutely. So let's go ahead and get that done. If we subtract here, we will get 1,273 minus 670. So our difference here, or the number of pages that were read by Anthony, would end in a 3, then 0. Then we have 12 minus 6, which is 6. So 603 pages were read. So even if you set this up with y equals mx plus b, you'll notice that once you subtract the b from both sides, once you subtract the 1,273, you'll get negative 603. Your final answer will be negative because the rate is negative, because you start with this many pages, you end with this many pages, so your number of pages is going down as you continue reading, a negative rate. But if you do it this way, you're just talking about it in terms of the pages that were read. No need to worry about positives and negatives. And then you have the rate times your time, which was 9. So then once we have that, boom, we're good to go, because now we just need to go ahead and divide both sides by 9. The reason, again, that we subtracted, Arthur, is because, well, hey, if we're using distance equals rate times time, we're looking for the time, how long Anthony was reading for. Or we're looking for the rate that Anthony was reading at. So when we're plugging things into the formula, we need to know, again, the rate for his reading speed. We need to know the time for how long he was reading and the distance for how many pages were read. We don't want to put in just the 1,273 because that's how many total pages he has left to read, not the number of pages he read. He had this many pages to read in the beginning, this many left at the end. So if we take the difference or subtract, we can figure out how many pages were actually read. So knowing that, now our formula is consistent. And once we divide by 9, we know we'll get the correct answer right away. We go ahead and divide, That cancels out. We end up getting our rate equals, I got you, Chiari. So from there, we'll divide. So we'll put 9 into 603. 9 goes into 60. That would end up being 6 times. We subtract 54 to get 6 remaining. Drop 3. 9 goes into 63 7 times. And that would give us our rate here as a perfect quotient, 67 pages per hour, which is a pretty crazy reading speed. It's very possible. Plenty of people do it, but that's definitely above average. Definitely above average. Our answer is C. So again, I know I do take a little longer than we might expect to explain the question, but it's because we're hitting such a variety of learners that I want to make sure that I'm explaining it in your way. You know, in all the different ways that I try to explain it, I want to make sure I'm explaining it in your way. So my party people, how are we feeling about this one? Even if we made a mistake, do we see where that mistake was? Do we see how we could have handled it better? Do we see that? Good. Good. And again, if you were setting this up with y equals mx plus b, allow me to go ahead and do it here. Feel free to screenshot it. With y equals mx plus b, you would have set it up like this. So what we'll be looking for here is the m, is the rate. And so we would have plugged in the 670. That was the ending page. Then we have the rate that we're looking for. The time is 9 hours. And then the beginning number of pages that we had left was the 1,273. So this is what your setup would have looked like with y equals mx plus b. Feel free to screenshot that if you wanted to compare that later on. Hey, no worries. Again, you can use both of them. Anytime you have a rate, distance equals rate times time, it applies. You just have to make sure you know how to set things up. You're good. Yeah, I got you, Chiari. So there you go. Boom. I really hate that the green screen's really covering a lot of this up, man. I'll do better. I'll do better. Yeah, and to solve this, so to solve it from here, again, this is something that is secondary to what we're trying to achieve today, but to solve this, you start by subtracting this on both sides, because then you're just left with m times 9. So subtract first, and then divide by 9, and you're done. And that's it. Exactly. Subtract and divide. Yeah. So let's move forward here into question number 4, because I believe that was already 3. Yep. Let's go ahead and go into number 4. I know, I hate that it looks white. This is actually green. Before class ends, I'll go ahead and just take down the green screen, and I'll show you what this looks like, what it's supposed to look like. But for right now, let's go ahead and get into this next question here. We have yet another problem that could be considered distance, rate, time, and it could also be set up with y equals mx plus b. So again, this is arithmetic reasoning. If we're talking purely where you'll find this, this is unit 6. And this is y equals mx plus b word problems. That's what that is. So I'll actually just go ahead and stick to y equals mx plus b. Again, it's literally the same thing, but I'll go ahead and show you this way. So everyone, from the question sentence, what is it that we are looking for? What was the plane's rate of ascent? What are we looking for? Yeah, looking for rate. They're very clear there. They say rate. We look at the answer choices. Everything has feet per minute. Everything has feet per minute over there. So we absolutely want to take advantage of that to make sure we have our setup done correctly. So for those of you asking, how do we know that this is a y equals mx plus b problem? Well, here's the thing. Anytime that you have a rate with a beginning and ending amount, always y equals mx plus b. Because that's what y equals mx plus b is. So if I write this down, what we have is the y is the end amount. That's your end amount. This over here is your beginning amount. And then the m and the x, that's going to be your rate times time. This is your rate, and this is your time period. So feel free to write that out or take a screenshot of that if you need to. But that's exactly how the formula works. And as long as you're plugging things into the right places, you're done. It's super, super, super easy. Promise. I promise. So feel free, go ahead, copy that down, take a picture of it, do what you gotta do. Do what you gotta do. And now let's go ahead, plug some numbers in and show you again how easy it is once you understand the formula. So everyone, let's go ahead and look at the information. First sentence, the plane began ascending from an altitude of 180 feet above sea level at a constant rate over the course of 31 minutes. Let's take a look at that first number there. We have a plane began ascending. Again, a plane began ascending from an altitude of 180 feet. Everyone, which letter would 180 feet belong to? B, exactly, because that's the beginning amount. So allow me to highlight that in blue. So again, the beginning amount began from an altitude of 180 feet above sea level. So that's our beginning amount. I'll go ahead and write that down over here. So plus 180. Next up, we see that it says over the course of 31 minutes. Everyone, which letter does the 31 minutes belong to? Which letter does the 31 minutes belong to? Yeah, that'll be X. Sounds good. So we'll highlight that in red. Allow me to erase this part here. Highlight this in red so you can see specifically where I'm getting these values from. So we have the 30 right there. We're looking for M, we're looking for the rate. And now let's go ahead and figure out what the ending altitude was. Everyone, it says the plane finished its ascent at an altitude of 5,140 feet above sea level. So my math party people, thank you for that, appreciate you. Let me correct that, 31 minutes. But our final altitude is what? Our final altitude was 5,140. That's right. That's right. That's right. That's right. So in purple here, let me highlight that. Finished the ascent at that altitude. So I'll plug that in right here. Booyah. So we have everything we need now, everybody. We have everything we need. Now we can solve this and we're done. Now, for those of you that are asking me, hey coach, can we actually go ahead and set this up with D equals RT? Well, yeah, we can. And this is exactly what it will look like. So everyone, the first step over here is going to be, we'll subtract 180 on both sides. We'll subtract 180 on both sides. And once we do that, we see that we'll have the cancellation over here on the right. But then 5,140 minus 180, it'll end in a 0. 4 minus 8 can't do that, so I'll borrow to get 14. 14 minus 8 would be 6. Then from here, you can borrow again. 10 minus 1 is 9, and then we bring the 4. So we have 4,960 equals 31m. My party people, this right here is distance equals rate times time. The distance that we ascend is 4,960 because we started at 180, ended at 5,140. So the distance that we cover is 4,960. Do you see that, everybody? This is distance, this is your rate, and this is your time. I swapped them out because obviously m times 31 and 31m are the same exact thing. But everybody, do you see that this form right here is distance equals rate times time? The distance we covered, the time it took us to cover that distance, and we're looking for the rate. This is the same form. Like I said, y equals mx plus b and distance equals rate times time. They are, in many respects, the same formula. So again, last time I'll ask, does this make sense? Before we move forward, let me know. Cool. Sounds good. So the last step that we'll take here, now that we've brought it together from both angles, what we'll do here is we'll divide both sides by 31 and we're done. Divide both sides by 31 and we're good. So this will take a little bit of work here on the side, totally fine. So we'll go ahead and say, hey, 31. We're going into 4,960. 31 goes into 49 just once. Subtract that 31, giving us a remainder of 17, or 18, excuse me. We drop that 6. Then we ask ourselves, how many times does 31 go into 186? And the convenient thing is that it's actually going to be not 5, it's going to be 6 perfectly. The perfect 6, because 31 times 6 is actually 186. 30 times 6 is 180. 1 times 6 is 6, giving you the 186. And so we just have that last 0 there that we'll just go ahead and bring along. And so therefore, the quotient of 4960 divided by 31 is going to be 160 feet per minute. And there it is. So clearly my big old head is in the way, so let me go ahead and take myself out. But that's how we get the final answer here of 160 feet per minute. So again, everybody, how are we feeling? How are we feeling? You know, we're mixing these topics up together in this class today. How are we feeling? Yeah, it's okay if you guess and you got it right, because remember that the point of this is not going to be ever. It's never going to be, you know, just solely focusing on getting questions right or avoiding getting questions wrong. You know, really the goal should be, can I explain why the correct answer is correct? Can I explain why what I did was incorrect? We have got to be willing to put ourselves in that position to get there. Yep, same. The next set of questions are going to be of the same topics. So the last question is going to be the quickest one. This one is going to be talking about a ratio and proportion. This one's actually going to be super quick, because we see that they tell us that the ratio between males and females, it's 19 to 19. Everybody, if there's the same number of males as females, well, that's exactly what that sounds like. There are the same number of males as females. So they're asking, hey, look, if we have 152 females, how many males? Well, if we just said that we have the same number of males as females, well, then if we tell us, hey, we have 152 females, that's 152 males. This is the fastest question here of the day. Not going to do too much explaining because it doesn't warrant that much explanation. It is a proportion question where we compared males to females and we saw that they are the same thing, same comparison. So bam, if we have 152 females, we have 152 males. Done. Yep, exactly. You should have the same. So does anybody need me to explain this even further? Does anybody need me to explain this one even further? Yeah? Okay, cool. So again, just to show you the proportion, remember that when we set up proportions, write this down because it sounds like some of us don't have the experience yet with proportions. No worries. So here's the main idea for proportions here. The main idea for proportions is compare the same things in the same way. So over here, compare the same things in the same way. And there we are. Compare the same things in the same way. Booyah. So if the numbers are different, you'll just basically still use the cross multiplying divide technique. So essentially, here's the proportion and here's what it will look like. We are comparing, we're trying to see, hey, look, we have how many males and we have this many females. So we'll just say males up top, females on bottom. We're looking for the number of males. We have 152 females. We're going to set the proportion up on the other side the same exact way. That's what that means. If we have males on the top, females on the denominator, same thing. Males in the numerator, females represented in the denominator, and so we'll do it in the same exact way. With this here, though, with this first sentence, and we see that it says 19 males, and then we have 19 females. So if you take a look at this, well, hey, look, 19 divided by 19, that's going to be 1. Whatever this divided by 152 is, has to be 1. So that has to be 152 because 152 divided by 152, that's 1. 19 divided by 19, that's 1. This needs to equal this. Or again, you could also cross multiply and divide, but this one is so obvious that we actually don't need to do anything else here. We can just say, hey, look, it's 19 to 19, so that's 1 to 1. So 152 times 1, it's just 152. So if we needed to solve this, we would go with the cross multiplication and division technique. We would go with cross multiplying and dividing. So Chiari, what's the difference between proportions and distance equals rate times time? I feel like I would get confused if a proportion question, or if it was a proportion question, but it has the word rate. So there's definitely a possibility of those two things blending. So the situation that I immediately think of is the wage question, where we say, hey, you earn, $14.50 for every hour that you work. How much would you get paid for 50 hours at the same rate? That can be solved as a proportion or a distance equals rate times time. Either way is fine. Either way. So it really just depends. With the experience that you'll get, with the practice you'll get, you'll see that a lot of these questions could, you have your discretion, but you first have to be able to differentiate between what you're seeing. Yeah, with proportions, exactly. You're comparing these two fractions, which you'll see that the simplest way to solve is cross multiplication and division. So we'll see another example of this for sure. But that was the 5th out of 5 questions, everybody. How are we feeling? Are we ready to tackle another set of 5? Are we ready to tackle another set of 5? Yeah? All right, sounds good. So before we get to that set of 5, I want to go ahead and keep things fair. I told you guys I would go ahead and show y'all what it looks like without the green screen. So this is what the taco actually looks like. Again, we have a lot of lettuce here and stuff like that. There it is. That's what it's supposed to look like. Obviously, got a green screen behind me. So unfortunately, I'm see-through, but whatever. Tacos are meant to be eaten anyway. So there we are. Yeah, extra guacamole is what it looks like too. Yep. Yeah, there's a lot of guac on here, a lot of lettuce, cheese, tomatoes. Don't see any beans. Got some chicken, but obviously I'm getting off topic. So let's go ahead and dive into the next one here. You guys have been awesome today. Let's go ahead. How would you guys prefer we do this? Do you prefer if we just go ahead, do the question, give you the answer, the quick setup, then move on? Or do you want to just go back to back to back to back and then review them from the beginning? Which way? Back to back, or review immediately? Okay, we'll go ahead and go back to back. Sounds good. We'll do the same thing then. We'll go back to back to back to back, and then we'll review those questions afterwards. No problem. I got you. So let's get this timer back up. Here we are. Sweet. And here we go. 3, 2, and 1. So I'm actually going to go ahead and give you the answer here because this one's pretty quick. The answer here is actually going to be A. And so the difference between A and B is going to be the way that you interpret the rate, the M. M here is going to be negative 260 for the simple reason being, everybody, that we are shipping 260 microphones per hour. Now, what does that mean in terms of the grand total? Everybody, we're talking about how many microphones are in the factory's inventory. So everyone, if we are talking about the inventory, if it's this high at the start, if we are shipping away the microphones, our inventory is going to go down. Because the more microphones we ship, the less we have in the inventory. So that means that your rate, your 260, must be negative, and that's this one here. Negative 260x, where we have a positive 260 here. So thankfully, that explanation was pretty quick, and it looks like a lot of us do understand the difference between A and B. So I'm glad that you do. There we go. And even if we don't remember, this is going to be Arithmetic Reasoning, Unit 6. Unit 6. And remember, if you haven't finished the math basics yet, then it's okay if this doesn't make sense. But let's move forward into the next question. 3, 2, and 1. Let's go. Alrighty, so the correct answer to this question is going to be C, 10 hours. So to set this one up, again, we can go 2 routes. If we went the y equals mx plus b route, if we went this route, here's what your setup would have looked like. Your setup would have looked like, hey, we are now on page 569. We are now on page 569. So that would mean that this is the end result. Then we know the rate. The rate was the pace of 48 pages per hour. So that's going to be 48. Then we see over here that we began on page 89. So that's going to be right there. That's your B. And then the time is what we're looking for, or the X. So this is what the setup would look like in this case. If you wanted to use distance equals rate times time, you would instantly have 480 equals your rate of 48 pages per hour times time. The way that you get 480 is because you're looking at the number of pages that were read to understand the time that we were reading for. And so you take the difference of 569 and 89 to get that 480. But remember that if you go ahead and solve this equation on the left side, you get the same exact thing. 480 equals 48x. They are both, again, the same exact formula. This one over here on the left just takes into account the beginning value and the ending value. What distance equals rate times time does is it basically just tells you what the distance was, what the difference is from the get-go, as opposed to looking at the end and the beginning. We just talk about what was the in-between. But again, they are the same exact formula. My party people, does that make any more sense than it did before? These two formulas are the same. They are the same. One just tells you, hey, we have space here for the beginning and the end. The distance here in DRT just tells you what you covered, what the in-between was. But again, they're the same thing. Sweet. Let's go ahead and dive into the next one here. 3, 2, and 1. Here we go. So let's get this timer out of the way. Let's bring my ugly face back into frame. Let's go ahead and try this one out. So my party people, let's go ahead here and understand what it is that we're trying to find. So this is a proportion question, and this falls under Unit 2. So this is Arithmetic Reasoning, Unit 2, right there, okay? This is proportion, and specifically exactly, D, this is a part to total question. This is a part to total question. So when we check this out, the question reads over here, how many total sticks are there if 54 purple sticks are in the bag? So here's the thing. The best way to set up a proportion is going to be based off of the question sentence. So that red highlight up there, how many total sticks if we have 54 purple? If we set that up as the first part of our proportion, we definitely should base it off of the question, because that's the information that you have as a relationship. We're looking for how many total, and we have 54 purple. So let's write that out. We have total here, and then purple over here. And so again, that's the consistency that we want to follow. We want to compare the same things in the same way. And so here we have total to purple. So on the other side, we need to be comparing what over here, everybody? What belongs in the top right? If we're doing total to purple on the left side, what's going to be total up top? Red, not quite. We just need to be consistent. If it's total to purple, it will be total to purple. It's going to be the same comparison, just drawing the numbers from this comparison over here. So this is, again, total to purple here on the right side in blue, and then on the left side, total purple, the red part. So hopefully that makes a little more sense. We're just comparing the same things in the same way across each scenario. On one hand, we're told that we have total is T, Purple's 54. Now we need to figure out what that is over here. So when we read this and it says the ratio of red to purple, the ratio of red to purple is 12 to 36. That means that red is 12, purple is 36. My party people, the order matters. Does that make sense there for everybody? Again, red to purple, saying 12 to 36. That means red is corresponding to 12, and then purple corresponds to 36. Cool. So with that said, we're good. We'll plug things in. So we see here that purple 36 sounds great. We'll plug that in right there. But here's the problem. Everyone, who here put 12 up top in their setup? Who put 12 in their setup? Okay, so if you put 12 in your setup, the answer that you would have gotten was not going to be the correct answer. The answer that you would have gotten would have been 18. However, 18 would not be the answer. 18 represents the number of red sticks. And so to get the total, you would have had the 18 red sticks, the 36 purple sticks that you already have, and from there, you could then go ahead and add those values together. And then you could attempt to get an answer. So with that, would that have been 1236 divided by 3? Yeah, that would have been 18. And then from there, yeah, would have been a little different. So let's go ahead and aim to get the correct answer. Instead of putting 12 here, again, it wouldn't belong. If we're trying to get the total right over here, so if we want to compare it with the total up top, we need the total over here. If it's 12 red and 36 purple, what's going to represent the total, everybody? What's going to represent that total? Grizel, you put 48? Yeah, and we're supposed to add things up. Because if we check things out over here, if we have 12 red, 36 purple, how many total? Well, we'll just go ahead and add them together. Just go ahead and add them together. 12 plus 36 equals 48, and that is 48 total. That is what represents the total parts. So we plug that in right over here. Right over there. Oh, no worries, Kiari. So again, that's how we learn. That's how we make that incremental bit of progress. So now that we have this set up properly, now we can go ahead and solve this problem the right way. So remember, the easiest way to solve a proportion, or the most straightforward, the most straightforward is always going to be to cross multiply and divide. But one thing that I always teach you is, remember, you don't need, I think I erased more than I had. There we go. So one thing that we can always do, or try to do, is simplify before we get into the crazy calculations. So if we look over here, everybody, we have a fraction. 48 over 36, that's a fraction. We can simplify that, everybody. What number goes into both 48 and 36 that we can simplify? 6 works, but is there a bigger number? 12, yeah. 12 is a slightly bigger number, and it's the biggest one that we can actually use to simplify these two fractions. And we can definitely do that. We'll go over here. We'll divide both the top and the bottom by 12. And look at the relief that this gives us. Because now we have t over 54 equals 48 divided by 12, that'll be 4. 36 divided by 12, that'll be 3. Look at that. This makes this a much more manageable situation than figuring out what the product of 54 and 48 is. I don't care what that is. I don't want to do that if I don't have to. So simplify first. Give yourself an easier time. Much easier time. I can't even see through this shell to see the screen, but yeah, there it is. So with that, now what we can do is, if we wanted to, we could proceed with cross multiplication and division, or if you wanted to do horizontal comparison, you could, because 3 multiplied by 18 is what's going to give us 54, so we could multiply by 18 on the top to get it, but if we didn't see that, no worries. T times 3, that's going to be 3t. And then 54 times 4, that would give us 216. And I know that because 50 times 4 is 200. 4 times 4, 16, 216. Now, from here, we'll go ahead and divide both sides by 3, and we're done. So 3 goes into 216 how many times? Let's find out. 3 goes into 21 7 times. Then we have 6. 3 goes into 6 twice. That would be, again, 72. Boom. So the total number of sticks that we have, it will be 72. And that is answer choice B. And there we are. So my party people, does that help you out a little bit when it comes to understanding proportions? Understanding that it's all about comparing the same things in the same way. Diego, what I think that you did was, hey, if you went ahead and set up your proportion in this way, if you did t over 54, let me get a different color here, better pen. If you did t over 54 equals 12 over 36, you would have gotten t accidentally equals, you would have gotten 18. But if you would have added the 18 back to essentially what you had before, the 54, then you would have gotten the correct answer. Because if you would have added both of those together, then you would have gotten 72 at the end. So again, if you didn't put 48, if you kept it as 12, you would have gotten 18 for that final value, but that actually represents the number of what? The number of red sticks. So because the number of red sticks is 18, the number of purple sticks is 54, we add these together to end up getting 72. So my party people, let me know if that makes sense there. That's what you did, Diego? Yep, that's the more common method. But again, you have to understand that, yeah, you're not getting the total when you solve that proportion. You're getting the number of red sticks. So then you take that and you add it back with the purple to get the final answer. So it really does matter what the numbers mean. You know, I could throw whatever numbers I want, but can you read what the number means in terms of the context? That's what's most important. Kim, you got the ratio, simplified it to 1/3 or 1:3. Excellent. So then purple 6 was 54. That means red is 18. Then you added it back. Excellent job, Kim. That works just as well. Excellent. So with that, everybody, it is 7:44. So here's what we're going to do. Now for the last 4 questions, because you guys are all here in the program and you know what topics we've dealt with today, Unit 2, proportions, Unit 5, distance, rate, time, Unit 6, y equals mx plus b word problems. Now for the final 4 questions that we're going to do back to back to back to back, I'm simply going to give you the answer and we're moving on. That way we can do 2.5 minutes per question and get a full 4 in. Everyone, does that make sense? Are you ready? Excellent. Sounds good. So again, I am not ignoring you if you're having trouble with these questions. I want to make sure we get as much more practice as we can. So here's the first of the 4. 3, 2, 1. The timer has started and my ugly face is out of the way. Do your best, guys. Good luck. All right, that's correct. Yep, the correct answer here is D, 6 to 19. That is the ratio of burgers to hot dogs. Let's go ahead and get into the next question. We will have it in 3, 2, and 1. Yep, this is going to be a proportion word problem. Although it does look like percentages are involved, percentages are only used to represent the actual number of miles that are run compared to the percentage of daily calorie intake. So this is Arithmetic Reasoning Unit 2. This is a proportion word problem. And the answer here would be B, 67.5. Your setup would be 20.25 miles over 15% equals the same, the number of miles that would attribute to 50%. There's your proportion. Solve that and you'll get 67.5. So feel free to take that screenshot. I'll give you a few more moments here. I'll give you 5 seconds to go ahead, take that screenshot, and we're moving on to the third question here. 3, 2, and 1. So the final answer here for this question is going to be C, 11 hours. And here's why. So for those of you that thought that this was a very similar question to what we did yesterday, it is. But the only difference here is that it says that we are traveling in opposite directions. Right there. We are traveling in opposite directions, meaning that the distance is added together and so are the rates. Opposite directions means add the rates. So with that said, booyah, we have ourselves our distance equals rate times time, but our rate is going to be the 60 miles per hour and the 90 miles per hour added up because they are traveling away from each other. So that would be 150 miles per hour. So you have 1650 equals 150t. Dividing both sides by 150, that gets you 11. 11 equals t, and that would be your final answer. So don't worry about the mathematics behind it. Worry more so about the setup and how we were able to understand that the distance was this, the rate was this, and that's how we got the time. But there it is, my math party people. So because you're here at the end of this video, I can probably assume that you're interested in more ASVAB help. And if you are, then go ahead and try my full program for free for a full week before you end up making a purchase. That way, you can see exactly how it works and exactly how it's going to help you succeed. To get started, go ahead and text TRIAL to 833-321-0182 or scan the QR code right there. Follow those directions and let's ace the ASVAB.